Good day. So today I'm going to teach you about vector diagrams. We'll start from the basics until the higher levels. So let's start with the definition of a vector. What is a vector? A vector is something that has got both magnitude and direction. So for instance, if I draw something like this, let's just say this is 10 centimeters long. If this is 10 centimeters long, and let's say I use 1 centimeter to represent, let's just say 2 newtons, then it means this would represent 20 newtons. So this that I drew is a vector because it has got a certain size, right, magnitude, and it also has direction. So this is a vector. So let's look at this scenario. We have got two forces. One of them is 15 newtons in the positive x direction, and the other one is 20 newtons in the positive x direction as well. If they ask us to find the resultant using the head-to-tail method, this is how we do it. We first have to start with a scale, right? We always have to use a scale to represent. So let's just say I'm choosing 2 newtons, or rather, let's say I'm choosing 1 centimeters. Let's say I'm choosing 1 centimeters to represent 2 newtons. So in this case, if this is 15 newtons and 1 centimeters represents 2 newtons, it means I would have to draw an arrow of length 7.5 centimeters, right? Because 1 centimeters represents 2 newtons. So I'm going to have to measure 7.5 centimeters in the positive x direction, so meaning that it's going to go to the right. So it's going to be horizontal in this case. So we're going to measure 7.5 centimeters, which would be just this that I drew. So basically, now when I'm drawing another arrow, the 20 newtons arrow, whenever I'm drawing it, so since it's the next arrow, when it comes to the head-to-tail method, the head of one must connect to the tail of the other. That is head-to-tail method. That's why it's called head-to-tail. So we're going to have to draw another one, and now we're going to have to measure. So since 1 centimeter represents 2 newtons, it means that I have to draw an arrow of length 10 centimeters. So I'm going to start from the head of one of the previous. So if I measure 10 centimeters, it would end here. So this is basically head-to-tail method because the head of one continues, it's connected to the tail of the other. So this is why it's called head-to-tail, right? And always when it's head-to-tail method, the resultant always starts from the tail of one to the head of the other. So it's kind of like as though it's reversed, right? It's connected tail to tail and head to head. So the resultant starts from the head of one to the tail of the other, right? The tail of one actually to the head of the other. Since it's head-to-tail method, the resultant is the tail of one to the head of the other. So if I want to find out my resultant, if I want to draw the resultant vector, because this is the 15 newton vector and this is the 20 newtons vector, right? So if I'm drawing my resultant, I will have to start from the tail of one to the head of the other. So I'm going to start from the tail of one to the head of the other. Then from here, I would have to measure them. So after measuring them, you should find out that actually measuring the resultant, that's what I mean. So after measuring the resultant, we should get the result as, so when you measure it, it should be 17.5 centimeters, right? I'm just using logic, but if you measure it, it should be 17.5 centimeters, which would represent 35 newtons, right? So this would represent 35 newtons. So that's the resultant, 35 newtons in the positive x direction. So we don't only specify the magnitude, but also the direction, right? So it's going to be 35 newtons in the positive x direction. Here is another scenario. So we have got one force that is 20 newtons to the east, and the other one is 15 newtons to the west. So I'm going to represent, so let's say one of them is 20 newtons to the east and the other one is 15 newtons to the west. So we're going to use the head-to-tail method. So if I draw one, I'm gonna use the same scale. Let's just say the scale is 1 centimeters represents 2 newtons. So if this is 20 newtons, it means I'm gonna have to draw a length of 10 centimeters, an arrow of length 10 centimeters, and east is towards the right. So let's measure 10 centimeters there. So this is where it would end. And then the other one is 15 newtons, but to the west. So if we wanted to, we could have actually drawn it that way, right? But then it's head to tail method. This is head to head, so it's not gonna work. Head to tail means that the head has to be connected to the tail, but it has to first face that side. So what will happen? It means that it will coincide. So we're gonna have to measure 15. So 15 newtons would be 7.5 centimeters. So we'll have to measure 7.5 centimeters going that direction. So it would be right there. So this is where the arrow would be drawn. So the other arrow would have to face that side. So the head of one will have to be connected to the tail of the other one. So it would have to go that side. So they just kind of coincide, they kind of mix up, because it's head to tail method. This one faces the right, the other one faces the left. So it would have to start from the head of one, right? Would have to draw it from the head of one. So it will go that direction. So in total, the longer one is 20 newtons. The shorter one, which is facing the other way, is 15 newtons. And head to tail method, the resultant is always from the tail of one to the head of the other, right? So the resultant is from the tail of one to the head of the other. So from the tail of one to the head of the other. So that space that is there. So we draw it from the tail of one to the head of the other. So it means this is the resultant that I just drew. And then we're going to have to measure the distance. So the distance there should be 2.5 centimeters. So 2.5 centimeters, now we have to convert that to newtons. So that would be 5 newtons. So it means this would be 5 newtons. So the resultants would be 5 newtons to the right, because we connected it from the tail of the longer one to the head of the shorter one, right? From the tail of one to the head of the other. So that's what we did. So head to tail method, the head of one must connect to the tail of the other one, right? So notice this head connects to the tail of the other one, and then the resultant is from the tail to the head. So the method is head to tail, resultant tail to head. So we kind of say it in reversed order. Here is another scenario. So this one is 15 newtons to the north, the other one is 20 newtons to the west. So let me use the same scale. So it's going to be 1 centimeters represent 2 newtons. So if I draw it, I would have to measure 7.5 centimeters. So north, right? So 7.5 centimeters. Right, so it would be right there. So to the north. And then I would have to connect it because it's head to tail, right? So since I started with this one, the other one must start from the head of the previous, right? So this is 20 newtons to the west, so it means I have to measure 10 centimeters to the west. So there, notice, from the head of one to the tail of the other. The head is connected to the tail of the other, right? And then from here, I have to now find my resultant. My resultant is always from the tail of one to the head of the other, right? If we draw it backwards, it will be from the head to the tail. But remember, the method is head to tail, so the resultant is tail to head. So from the tail of one to the head of the other. So if I draw it, this is how it would be. And that's the resultant. And then from there, I now have to measure the distance. So this is 13.5 centimeters, right? Now this means that it would be 27 newtons, right? So the resultant would be 27 newtons. And then from there, you're gonna now have to use a protractor, right? So when we use trigonometry, this is 0, 90, 180, right? 270, and revolutionary is 360, right? So you're gonna have to put your protractor. Unfortunately, I don't have it, right? When we put our protractor, it has to be somewhere there, right? Then we have to measure from there and see how many degrees is this whole space. So we have to specify the direction as well, right? So if this here, it would be somewhere like 150 degrees, right? Somewhere 150 degrees. If I were to place my protractor here, it would be somewhere like 150 degrees. So then I would say my resultant is 27 newtons and 35 degrees. 150 degrees. Why am I saying 35? 150 degrees, right? So we always measure it from the 0 position, going that side, going anti-clockwise, right? So this direction is clockwise, right? This rotation is clockwise, and the opposite direction is anti-clockwise. So anti-clockwise, that's how we have to measure it, right? So the direction, so this would be 27 newtons, and the degrees would be 150 degrees. So both magnitude and direction is needed. So you would place a protractor and you would measure, you would find out how many degrees is it. It should be around 150 degrees, right? 150 or 155 degrees. Should be around that side. So here is one scenario, 20 newtons south, the other one 10 newtons south, the other one is 20 newtons east, right? So let's draw the one of 10 newtons. Let me represent the same scale. 1 centimeters represent 2 newtons. So in this case, 10 centimeters south. So this would be, let's just say, okay, south, right? 10 centimeters. All right. Right, so of course my arrow has to face downwards because it's south, and the other one would be 20 newtons to the east, right? So east is to the right, so I have to connect it. I have to start from the head of the previous, because it's head to tail, so I have to connect the tail to the head, so it's to the east. So it would be something like, alright, there's just something that I did there, just a small mistake there. I said 1 centimeters is 2 newtons, so it means I'm supposed to measure 5 centimeters and not 10, right? 5 centimeters, so it's supposed to be right there. Okay, and the other one would be what? It would be 10 centimeters this time. All right. Okay, so from there we now have to find our resultant, right? So this is the 20 newtons force, right? And this is the 10 newtons force. So to find the resultant, we connect it from the tail of one to the head of the other, right? Remember, method is head to tail, so the resultant tail to head, right? So we're going to have to connect it from the tail of one to the head of the other. So this will be the resultant. Now we're going to have to measure it, right? So when you measure it, when you measure it, it should be, so it should be around 11,1, right? So from there, 11,2 centimeters. Now, when we represent that in newtons, it's gonna be 22,4, right? So it means this is gonna be 22,4 newtons. And of course, you're gonna have to now specify the direction, right? So notice the arrows towards that side. So we're gonna have to specify the degree. So if you use a protractor, notice if you go clockwise, right? If you go clockwise, it would eventually pass 180 degrees, because 180 degrees would be somewhere there, 0 degrees would be somewhere here. So it would eventually pass 180 degrees. So you're gonna have to continue. So it means you're gonna have to turn the protractor upside down, and then you're gonna have to measure this part. So it should be around somewhere like 330 degrees, right? So it's gonna be 330 degrees. So the issue we had there is we had an arrow facing this way, and when we use a protractor, 0 starts from here, so we're gonna have to go all the way, right? All the way. So it should be around 330 degrees or 340 degrees. Here I'm just playing guesswork because I don't have a physical protractor, but I hope you get it. So when we measure it, we're trying to measure the direction of this arrow, right? So 0 starts from there. So we're gonna have to go all the way, right? Just like what I did here. 0 starts from there, so the horizontal part is 0, right? From the tail of 1, if you connect the protractor horizontally, 0 would start from there, so you're going to have to go all the way up until it touches there and measure the degrees. So you're going to now have to flip it, because we know eventually it's going to reach the full length of it, which would be 180 degrees this side. Now we're going to have to flip the protractor upside down and measure how far will it go. So it should be around 330 degrees. You can even measure the degrees, and let's just say it was something like 150 degrees. So if you say 150 degrees, then you add it to 180, it will give you 330 degrees. So if you turn it upside down, whatever you measure there, you would now have to add 180 to it, right? You now have to add 180 to it. So when you turn it upside down, and it gives you something like 150, if you say 150 plus 180, it will give you 330, because of course the protractor doesn't have those big degrees like maybe 190 or 200. It stops at 180. So when you flip it upside down, we now have to measure it, and the answer we get, we have to add 180. So I hope you get this part, because we have passed 180 already. So when you turn the protractor upside down, when we measure it, the answer we get, we have to plus 180. Here is the last level. So if we're given 4 forces, let's just say we're given 4 forces, and we're asked to calculate the resultant using the head to tail method. So we're gonna have to draw all this, right? So let's begin to draw. So I'm gonna use, my scale is gonna be, let's say 1 centimeters would represent 10 newtons. So in this case, or rather let's just say 1 centimeters represents 20 newtons. In this case, 200 newtons would be 10 centimeters, right? So it's gonna be 10 centimeters. So I'm gonna have to draw a line of 10 centimeters at 45 degrees. So if I were to start here, I would have to use a protractor and measure 45 degrees. 45 degrees would be literally somewhere there. So now I would have to measure 10 centimeters, right? So 10 centimeters would be somewhere there. Yep. All right. I might have to bring this down. Yep, I might have to bring it down. Let me just bring it down just to add some space there. So let's just say I choose to start here. So of course if I use a protractor, right, 45 degrees would be somewhere there. So if I measure 10 centimeters, it's gonna be right there. Okay, so now let's say okay, let's draw the next one. So of course I started, so this is the tail and this is the head, right? Now I have to draw the other one starting from the head, right, so that the head can connect to the tail. So this is 100 newtons at 135 degrees, so I would have to start here. So 135 degrees would be somewhere there, right? 135 degrees if you use a protractor. So if this is 100 newtons, it means it's gonna be 5 centimeters because of my scale. So I'm gonna have to measure 5 centimeters. And then we have it. All right, and then now we have to draw the next one, which is 15 newtons. So 15 newtons at 270 degrees. So 15 newtons in this case, so it would be 2.5 centimeters. So 2.5 centimeters would be somewhere there at 270 degrees, right? Because if you use your protractor, and let's just say use a protractor, it's gonna be more than 180 degrees, so you will have to turn it upside down, and you would have to measure 90 degrees upside down, so that can be 270. Besides, remember 270 is there, right? This one is 0, this is 90, and this is 180. So 270, it's like vertically downwards. All right, and then the next one is 20 newtons at 180 degrees. So 20 newtons at 180 degrees. So if you use a protractor, 180 would be somewhere there, right? So 20 newtons, you're gonna have to use, okay, 180, it's right there. So 20 newtons would be somewhere there. It ends here, literally. And then we have it, all my 4 forces. Now the resultant is always from the tail of one to the head of the other. So let me draw my resultant force right there. So that's gonna be right here. And if we measure it, it's gonna be how many centimeters? That's gonna be 7 centimeters, right? So 7 centimeters. Now we have to convert it to the forces, right? So 7, that's gonna be 140, right? So it's gonna be 140. We have 140 newtons. So there we have it, 140 newtons. But here's an issue. I only got the magnitude. We also need the direction. So if you use a protractor, right? Let's say you use a protractor to measure this stuff. This would be around 85 centimeters, right? 85, not 85 centimeters, I mean 85 degrees, right? If you use a protractor. So it's close to 90 degrees. So we would then say it's 140 newtons at what? At 85 degrees. Okay, this looks really close to 90. I'm playing guesswork, remember. This looks really close to 90. Let's just say it's 88 degrees. But of course, when you do this stuff, you now have to use accurate measurements. So there we have it. There we have it. So you basically draw one by one and make sure that the head of one connects to the tail of the other, right? And whenever you find the resultant, it must start from the head of the tail of one to the head of the other. For example, if the head of one of the forces is here and the tail of one of the forces is right there, let's just say it connects to several forces. Let's just say several forces like that. Let's just say this was our diagram. Then your resultant has to be from the tail of one to the head of the other. So your resultant would be this space. You would now have to measure the magnitude and the direction. And we have it. So we end it here.